In the last exercise, we come with the use of the audio information. We have been using an external file or sound file like the WAV or AIF for playback within Pure Data. So in this exercise, we'll switch to the internal mechanism of the Pure Data. I will use, for example, the oscillation, which come with the Pure Data as a way to generate sound from a patch with no other external resources. So the DAC we have come across is the digital to analog conversion, which convert digital information to the physical sound through the sound device in your computer. In order to generate the audio information, we make use of some object like the oscillation. See, the OSC is the oscillator. We will create some form of sine wave or cosine wave, and the parameter it comes with will determine the frequency. We can put a number, and this number will be converted from an information to the frequency of the oscillation. And the oscillation audio information will be passed through the DAC and convert to physical sound through the audio device in your computer. So again, you need to turn on the compute audio. And you proceed to change the number in the number box. And the number will correspond to the frequency in Hertz where you would like to generate the audio information. And the one we have been using is by dragging the number box to change the frequency, which is the pitch. And if you would like to control, for example, the volume, you would perform something like the multiplication of the audio information like this one. So before we send out the audio information to the DAC, the digital to analog converter, we can perform some sort of mathematical computation. The mathematical computation also comes with the plus, minus, multiplication, and also the division. And what we are going to use is a multiplication with this particular audio indicator. The second inlet of the multiplication in the audio form also comes with the parameter where you can use a number to control the size. So in this case, I'll again use an horizontal slider with the property of the range from 0 to 1. And you can observe the implication of this particular parameter. So you can turn on the audio and then push the slider. Again, for the number in this number box, control the frequency. And the slider over here will control how much information you would like to multiply to the original audio information, and essentially it's become the volume controller. So a number 0 over here will actually mute the sound coming out from this particular operation. So this is one of the simple ways you can use it to, for example, to manipulate the volume of the audio, and also, for example, this playback or the stop of some sort of sound. So beside the OSC, the oscillation which generate the sine wave, in pure data you can have other form of wave. And this one is called the phasor. So if we take a look at the help information, so actually it will come up with some sort of sawtooth signal. So some of the time we call it a saw wave. So similar to the oscillation, we'll put in the number to control the frequency, and also the output will send out to the multiplication for the volume control. So you can notice the change in the timbre or the sound quality by using the phasor and also the oscillation, and they will give you some sort of control into the quality of the sound. So besides using the pure frequency like the oscillation or the sawtooth waveform, you can also refer to number in the MIDI convention. In computer music, each one of the key you find from the keyboard, for example, the piano keyboard, they will corresponding to one MIDI note number. So the smaller number will have the lower frequency, which is the lower octaves in your keyboard. So toward the right hand side of your keyboard, they come with a more higher number. So conventionally, the C, the middle C over here in the computer keyboard or piano keyboard, it's come with the number 60. So based on this one, so the higher the number, so the higher the frequency, and the higher it come with on the octaves. In pure data, we can also generate the sound by using the MIDI note number. And the command will be the make note. And make note come with 3 inlets. The first one is actually the number you have seen in the piano keyboard. So the 60 will be the middle C. And the second one will be the velocity. So in computer music or in performance, when you strike a key upon the keyboard, so the amount of pressure will be measured as some form of velocity information. So the harder you strike the key, so the higher the velocity number, and essentially it will create a higher volume for the sound. And this last number will be the duration, so it's the amount of time that particular note will be in effect. And the outlet will come up with the particular frequency number of the note. So what we need to do is we will convert this MIDI number into a frequency by using a secret command mtof. So the M stands for the MIDI, TO is 2, F is frequency. So this is some of the information related to the audio and also the MIDI information. And for this one, this actually will convert the MIDI note number in terms of the frequency. We'll create that particular frequency number. And the frequency number, we can feed it to an oscillation. And through the oscillation, we can use the DAC for the playback. So alternatively, you can also add in the multiplication in order to have some form of volume control. So for this one, you can simply hard code, for example, a number like 60, and the rest of them you put in some initial number. And for the first inlet, which controls the MIDI note number, you can use it to change. For the rest of them, if you do not want to change, you can just leave it. So you can notice whenever I change, for example, I drag the number box over here, it will generate that particular note through the make note command, and the note number will be converted to the frequency, and the frequency will drive the oscillator to produce the sound through the sound card. And you can also notice, for example, if I start the sound, it will continue to play in the oscillation. So in a lot of cases, you would like to stop the sound for a while and then you play for the next note to simulate, for example, a keyboard. So in that case, we'll make use of this particular volume control to start and then to stop the playing of the sound. So what I'm going to do is I'll put in two numbers instead of a slider. Like 1, I would like to have the full volume control over here, and the other one 0, which I'm going to like disable the sound playing by reducing the volume to 0. So in order for me to play back the sound and to disable the sound a while later, I need to add in some trigger control over here. So the key point is, in the very beginning, I'll use 1 as the volume to play back the sound with this particular MIDI number. and then after a while, and you use the 0 to stop the playback. And that particular after a while command will be a delay command. So for example, if you would like to delay for 200 milliseconds, you have the delay 200. And then after that delay of 200, you trigger the band to this number 0. And essentially it will disable the sound from playing. And the second step is how you would like to, for example, first register that delay, and then at the same time to put 1 over here for the playback of the sound. So what we are going to do is make use of the trigger command we have learned before. The first message we're going to send is this MIDI number from the number box. And the second one, we trigger the 1 as a volume control. And the last one, we trigger the delay to put in the 0 in the volume. And then we try to have a look of the effect. So you can notice that when I stop, so the sounds will stop after the delay of 200 milliseconds. So in that case, you can create something like a keyboard. For example, if I put in a number of selections by using the radio button, so with this radio button, I add in a number like 60. So that means in the very beginning, the first number will be 60, and then 61, 62, 63, and then 64. So this gives you some sort of control like a piano keyboard. So in that case, it comes with the 13 in the chromatic scale, which every one of them in a semitone. You can of course put in some of the control, like which one of them will be in the whole tone, whole note, and the other will be semi-note. Or alternatively, you can use multiple buttons like the band to have different number as a way to control the playback of the sound. So in this exercise, we have come up with very simple way of creating audio information from the scratch. So we start with using the oscillation with a number to produce a continuous tone. And then we also experiment with the phaser with different quality of that tone. So for this one, you can also replace it with the phaser with different quality of the sound. And the last one we have come across to make is to use the MIDI information from a MIDI keyboard by using that number to produce the sound and then eventually produce using an oscillator or phaser back to your sound device.